Hello, geometry students. I hope you're all being very good for Mrs. Savage. We are going to start Chapter 10, Part 1, Circles and Circumference. So we can identify and use parts of circles and solve problems involving circumference of circles. So let's get started with your packet. You should have gotten a packet after your test. And these are the definitions that you're going to need. So you can pause the video, or if you want to listen while I read these out loud, feel free to do so. I'm just going to go ahead and highlight this. I'm going to use a highlighter. So a circle is the locus or set of all points equidistant from a given point called the center. Okay, I think we all know what a circle looks like. The center, and we'll provide visual cues here in a little bit, but the center is going to be smack dab in the middle. The radius is a segment with endpoints at the center and on the circle. So it is going to be halfway across. That's how I remember it. So halfway. And then we have the chord, which is a segment with endpoints on the circle. So it can go from one part of the circle to the other. It doesn't have to go through the center. And then we have the diameter, a chord that passes through the center and is made up of collinear radii. So if you put two radii together, you're going to get the diameter. And so this is all the way across. Okay, so all the way across. So here's some visual cues for you. So I'm going to provide you or let you match these. So why don't you pause for a second and see if you can match these. Okay, so the center, this is going to be the center, circle C. The radius is going to be, we said, halfway across. A chord is with endpoints around the circle, so this is what a chord looks like. And the diameter is all the way across. So there are your visual cues for your packet. Now, the radius and diameter relationships. We should know that the radius is half of the diameter. Okay, so the rate, and that's going to help us. So the radius is half of the diameter. So we need to know that. And if you want to write that in your packet, that's fine. I don't have a problem with that. Okay, so suppose that QV is 8. We want to find the diameter. So if 8 is half of the diameter then is going to be 16. Okay? Alright, so a few key concepts here. Two circles are congruent if and only if they have congruent radii. Excuse me. All circles are similar, so they're all proportional. Concentric circles, this is in your packet, are coplanar circles that have the same center, so they have the same center. And this would be your visual cue if you want to put that in your packet as well, what that looks like. So feel free to write these down in a notebook. This for sure in your packet. Okay, so suppose we have a segment connecting two circles. Intersecting circles. These circles are intersecting. The segment contains the radii of the two circles. So notice how the radii are connected. So let's think if we can solve for CD. So the diameter of circle S is 30 units. Okay, so if the diameter of S is 30, what's the radius then? Yes, it's going to be 15. Okay. And if the diameter of circle R is 20, well, we need to know what the radius is. What's the radius? It's going to be 10. And DS, this piece right here, is 9. We want to find out what CD is going to be. So what is CD? Go ahead and see if you can figure that out. So what we are going to do is take 15 minus 9, and CD ends up being 6. Now what if I asked you if you could find RC? What would that be? Well, if we know that this piece is 10 and we know this is 6 right here, RC then would be 4. Very good. So you'll have a few practice problems like that. And the next concept, we got to learn circumference or review circumference. So circumference, there are two formulas for it, and it is the distance around the circle. So you could use 2 pi r, c equals 2 pi r, or you can use c equals d times pi. Whatever one you feel comfortable with. Sometimes you might use the diameter one, sometimes you might use the radius one. They mean the same thing, because 2 times radius is the diameter. So let's find the circumference of a circle with a radius 3. So c equals, I'm going to use this one here because since we have a radius, 2 pi times 3. Well, I'm going to go ahead and put my numbers together, 2 and 3, and that'll be 6 pi. And you should have a pi button on your calculator. If you do not, you can use 3.14, but your answer should be 18.84, and we got to remember our label, centimeters. So that's the circumference of the circle. Let's do another example. In this example, we are going to find the diameter and radius of a circle with circumference of 106.4 millimeters. So we're still going to use our circumference formulas. I'm going to use the diameter formula first. So I have 106.4 equals the diameter times pi. So to get diameter, or d by itself, I'm going to divide by pi on both sides. So 106 divided by pi gives us 33.87 is our diameter. And since we have a label of millimeters, I'm going to put that on there. So that's the diameter. Now how can I find the radius? The radius, remember, is half the diameter. So I'm going to take the radius I'm going to take the diameter and divide it by 2, because timesing by 1/2 is the same as dividing by 2. So my radius then ends up being 16.94 millimeters. Okay, very good. All right, that's all I have for you this video, and part 2 will be coming up.